How's it going, everybody? In this video, we're going to talk about IPsec. And the funny, cool, interesting part to IPsec to me is that how many people don't really get it. So what is IPsec? Well, IPsec in a nutshell is a way for you to encrypt data between two different routers. So, for instance, you could have a site in Chicago, you could have a site in Milwaukee, and you could have an IPsec VPN configured between them. As long as the router in Chicago and the router in Milwaukee can talk to each other via the internet, you can form an IPsec VPN. So, there's a couple parts to it that you have to understand in order for it to work. Now, technically speaking, IPsec itself is the data plane. ISACAMP is the control plane. So, the idea behind it, people refer to as an IPsec VPN, which technically is true. However, it's not entirely all the details to it. So in order for you to understand what IPsec VPNs are, you have to understand the parts to it. And this is actually what helped me understand it, was the breaking it down into smaller chunks so that I could understand what was going on. So normally what you're going to do between two different routers is you're going to make sure that you have reachability to each other. Then you're going to form the peering to each other via ISACAMP and using an IKE or Internet Key Exchange, and then from there you're going to form an IPsec VPN or the ESP configuration. And then with IPsec itself, you have to be kind of careful because you have to tell the IPsec process what traffic is allowed to go across the VPN and what traffic is not allowed to go across the VPN. So where is it coming from? Where is it going to? And this is done with an extended access list that you would configure and call from a Cryptomap. And the Cryptomap is going to allow you to apply that map to an interface so that you can say, Cryptomap whatever on the interface level. And so as traffic goes through that interface, if it matches the destination, then and it's coming from the right source, going to the right destination, then it will be encrypted. That's the general idea of how this stuff works. Now, from the cool thing about VPN, and this is separate from your MPLS VPN, your GRE VPN, or I should say your GRE tunnel, is that IPsec can pretty much encrypt whatever. So as long as you have reachability to the far end where you're trying to get to, and you have the correct proxy ACL in place, then everything else kind of falls into place. So why would you use one? I mean, is there a real reason for it? Well, in some environments it's needed, other environments not so much. So for instance, if you work in the finance industry, IPsec is probably going to be a requirement because of the fact that you're dealing with financial data, personally protected information. You're going to have some sort of Sarbanes-Oxley, or I call it Sarbox, or PCI is going to be a big one for credit card transactions and things like that. Those are all different reasons for you to use IPsec. Now, the ironic thing is I just finished up a project not too long ago, probably end of March, early April, working for a company that was actually based out of Ireland. So the company I was working for, they weren't U.S. based. So the company was headquartered in Ireland. I don't remember exactly where, but actually I do, but I can't say. But the company was headquartered in Ireland, but had several locations throughout the entire country, and so across the world even. I think we had. I was consulting on the project for a big link deployment that they were going to, and I believe it was 300, 400 sites, something like that. It was a very large number of sites. So the idea with them is they didn't need IPsec. They didn't. But then again, anything nothing that went across the wire was that was needed to be encrypted. None of it was sensitive data. And if anything did need to go across the wire, it went over the MPLS VPN. And for us, it was actually really, really simple because MPLS is a provider-specific technology, and we didn't have to worry about it. So you might think, well, provider-specific technology, what do you mean by that? Well, MPLS in itself is actually a labeling protocol, so multi-protocol label switching. And I will be covering MPLS to some level down the road, but it'll be after I get the majority of everything covered. Actually, this is outside. This topic right here, IPsec, is actually out of scope for the route exam, but it's hard to talk about GRE especially with DMVPN without covering IPsec, because literally every company that I've done IPsec work for, or DMVPN deployments on or work in, I've always had to deal with IPsec to some degree. And there's different ways of applying IPsec, and we'll talk about that as we go along here. But your typical VPNs, there's going to be two different layers. Layer 2, which is going to be your Ethernet VLANs and doing 802.1q tunneling, which is Q and Q tunneling. And there's a question: isn't that a service provider specific technology? Yeah, I guess. I mean, the idea with quality with Q and Q is what is commonly referred to as its coin term, if you will. Is you're going to have a layer 2 circuit going down to your edge device, and you're going to have a VLAN. And what you're going to do is on the provider side, so the upstream switch, the interface that you connect to that switch on, the provider is going to tell you, or is going to put that configure that port to be a switch port mode tunnel, or I believe that's the command. I have to actually look. It's been a while since I've configured one. But the idea is he's going to have a specific VLAN ID that he's going to attach to that tunnel, and as you go across that, you're actually going to have your tunnel your .1q tag that you associate to your interface. As soon as you hit the provider's device, you're going to have another .1q tag that's put in place of that. So it's going to be a Q and Q, so a .1q inside a .1q tunnel, and you're going to be routed via the provider's .1q association. And then when you get to your edge device, to where the traffic is going to end, then you're going to have that strip that outer layer off, or that outer tag, if you will, off, and you're going to be routed via the tag that you set. Now, MPLS works in some of the very same way. You have two different labels. You have a VPN label and you have a transport label. The VPN label does not change. The VPN label is specific to the route, so the subnet you're trying to reach. The transport label is going to change on a per MPLS forwarding capable device. The idea here is your VPN label is going to be specific to the route. The transport label is going to be specific to the PE or the P or PE device, provider or provider edge device you happen to be hitting. Now, the idea here is as you're going through, there's going to be a label mapping to an incoming interface and an outgoing interface for a particular route, and that's going to be a particular subnet. So when you get into it, I don't want to deep dive into it, but the idea is very simple. When you hit a provider edge router and you're coming from the customer to a PE device, so the customer or the provider's edge, you hit the provider's edge, and they take your IP forwarded traffic and they put a label in front of that. That label is going to be identified as a VPN label. That label is going to be specific to your route. Then when you have your traffic, when you want to get forwarded to the next hop, which could be more than likely is going to be a provider core router, so a P router, the transport label gets put in place. So the transport label gets swapped out, or swap and pop. I guess it would be, no, actually that's not true. Swapping is done on a per router device, per LSP device, or a label switch path device, where a imposition is where a label gets placed, a swap is where a label gets pulled off and a new one gets put on, and a pop means a label gets pulled off. So as you're going through the MPLS network, you hit a device, a label's pulled off, a new label's put on, you go to the next device. A label's pulled off, a label's put on, go to the next device, until you get to where you need to go. And then when you go from that router to where the PE device is, they do what they call a PHP, or a penultimate hop popping. PHP, or a penultimate hop popping, simply means next to last. That next to last part means that you're going to pull the transport label off for the traffic as a VPN label. When the traffic hits there, that VPN label is going to get pulled off, and then you're going to be routed down to the customer, the receiving edge, the receiving side, as an IP route. So that's a real high-level overview of how MPLS VPNs work, but that's a general idea for it. And like I said, I'll cover that more in detail later on. Now with IPsec, it's a little bit different. You have a extended access list that's going to match source and destination traffic. And whatever the source and destination is on the sending side is actually going to get flip-flopped on the receiving end. So your source is going to be 10.1.1.0/24. Your receiver is going to be 192.168.1.0/24. So you're coming from here, but you're going from 10.1 to 192.168. Then on the other side, it's going to get flipped. So your destination is going to be 10.1, and your source is going to be 192. So you need to make sure your proxy ACLs are set up accordingly. That's going to get called by a Cryptomap, which is going to be calling a transform set and some other characteristics. And those Cryptomaps are placed at the interface level where the traffic is going to go through. The idea here is when traffic hits there, the source and destination IP addresses are looked at. If they match the proxy ACL, the traffic is encrypted and forwarded over the VPN. If it doesn't match the proxy ACL, it's forwarded as just unencrypted traffic. Now, when we get into the details here, it's important to understand why you would need it. So, why would you use it? Well, it does not need a static service provider provisioning like MPLS. So, you don't have to have, as long as you have internet reachability to the far end, then that's all that matters. Everything else kind of just, whatever. The next thing that matters is, what are you going to do with it? How do you want to handle the traffic? So, the nice thing about it is, you can do both site-to-site and you can do remote access. Now, the problem with the ease of deployment with site-to-site is that when you have traffic coming from site A to site B, you need to make sure you have your proxy ACLs in place to make sure that traffic coming from site A going to site B can get back. So site B to site A, making sure you have your extended access list configured correctly is going to be a big thing. And there's a question: could it be in the same major subnet range, 10.1.1.0/24 to 10.1.2 on the remote end? Absolutely, that absolutely could happen. The main thing you need to pay attention to is you could do /30 to /30. It doesn't make a difference. Or you can do /32 to /32. You could do a host-to-host route. Now, the proxy ACL will be as accurate as you want it to make it, so you can make it really, really wide. But remember, the wider you make it, the more traffic is going to get encrypted. Now, we haven't covered CCNP switch yet. But when we get into CCNP switch, I'm going to have a section of the exam set up to where we talk about end-to-end VLANs versus site-specific VLANs, and how you would go layer 2 to layer 3, go across the internet or your WAN connection, whatever it might be, down, and you would be routing down from layer 3 to layer 2 again. Now, end-to-end VLANs are bad because if usually spanning trees involved. So if you have a site over here have a failure, then if end-to-end VLANs are configured and you have a spanning tree topology change notification goes across the wire, that means anything that happens here gets propagated over here. Same thing with like OSPF if you're doing a sham link over your provider edge, so you have area 0 routes on both edges of your MPLS domain. SPF runs here, SPF runs here. So I know I'm getting a lot outside of the scope here, but I will discuss this. If you want to know more about how sham links and stuff like that work, go check out my CCIE series. I actually cover all that. So the main thing to understand is the more specific you get with your site-to-site stuff or site-to-site configuration, the less traffic will be encrypted, which could be a good thing depending on the situation. Now, for remote access or RA VPNs, typically this is going to be SSL or web. These VPNs are going to be for traffic outside of your network, like a teleworker, somebody from home. You might have salespeople that have like an iPhone, which I personally can't stand. Apple devices, personally. I don't have anything against Apple in general. What I do have a problem with is the price of their devices. And if you're buying the Apple device for the specific, for a certain type of need, like you're big into gaming, or you've got you do like a lot of video rendering, or you're big into graphic cards, I can't really argue that Mac is better than PC on that. I mean, hands down, Mac is better than that. The problem that I have with Mac is that it doesn't integrate well with the Windows environments that I support. So that's why I have a hard time with it. Mac, and then there's other things like, I can't join it to a domain. unless I have special software in place. And I mean, there's some other characteristics come in place. Now, I'm not a Mac guy, so I might be missing some things. And there's a comment. What about Windows-based remote or Mac-based remote desktop? You can use they do have an application out there where you can do a remote desktop connection to a Windows box from a Mac. Yes, I understand that. But at the end of the day, I just don't see the value. That's just nothing against Mac. It's just me. But the problem with that being is, and nothing. I kind of got off topic there. Is that when you're dealing with your remote access, you're dealing with configuration that allows traffic from outside your network into your network. So, typically speaking, if you have a situation where you're outside the network and you're trying to get inside the network, you need to make sure you understand where traffic is coming from. So, you may not care. So you might have what do they call it? They're dynamic VTI tunnels, which is just a phase 2 configuration, which I'm not going to be covering in this video or this section at all. The general idea behind them is that when you have traffic outside your network that's trying to reach inside your network, and you have somebody at Starbucks trying to gain access, that could cause a problem depending on how your network is set up. And there's a problem how? I've had people try to connect in via a unsecured open wireless network, and the way that the network was set up, it wouldn't support it. And I'm not a security guy. I just know how to do. The only reason I know IPsec to the level that I know it at is because in the CCIE routing and switching version 5 lab exam, it's needed when you're dealing with a DMVPN. So that's the reason I need to know IPsec. Beyond that, I don't ever really work with it. I know how to do site-to-site VPNs, and honestly, I've never actually configured a remote access VPN before. So I'm not even going to touch that one. I'm not even going to try to figure out how it works. But as we dig into this more, we're going to find out what is IPsec, and it's a standards-based security framework for setting up secure connectivity between sites or between routers. So that the standards base is going to be a keyword for you because that means that you can use it with any vendor. So the actual syntax might vary slightly from vendor to vendor or how they do it. Usually if I'm going to be on I'll say a Cisco box and then a Juniper box, I'm going to be using a wizard as much as I can to set things up and going from there. And I believe there's some hiccups with Juniper. You have to do aggressive mode, I want to say it is. I honestly don't remember. It's been such a long time since I played with them. But the general idea behind it is if you have a situation where you're trying to do inter-platform VPNs, it's best to go look at the documentation if you can for those devices, because at the end of the day, that's where it comes into play. So now I'm not going to go into a lot of detail on how the all the background for IPsec, why you would use it, but just more or less, how it works from a high-level perspective, because, again, you're not going to get tested on this in this exam. It was tested on in the exam I took, and I didn't do very good on the IPsec part. I really didn't understand it. I knew how to create one, and that was basically just copying and pasting config into a router, and it would work. I don't have to do that anymore. I know how to make it work now. So the idea behind IPsec is to encrypt traffic. So basically, how they work is relatively straightforward. Tunnels are dynamically negotiated through IKE, or Internet Key Exchange. The main goal is to not define traffic or define crypto key manually. So IPsec uses two data structures to build a tunnel. So you have the SA, or Security Association. This is an agreement to make sure that everything works out. And then we have the SPI, or Security Parameter Index. So this is going to be the VLAN header. So they both had to agree on it. Now, when it comes to ISACAMP and IKE, are negotiation protocols. So ISACAMP and IKE, or the ISACAMP, when we deal with it, we're going to see brain fart. When we're doing our configuration and we're doing the verification, we're going to be doing a lot of show ISA-SA. Show ISA-SA, or so I should say, show crypto ISA-SA. That's going to be saying, what's phase 1 doing? So, and IKE is pretty much the same thing. So, ISACAMP, we're going to be doing ISACAMP, not IKE. We're going to be doing IPsec version 1. IPsec version 2 gives you a lot more capabilities. So what we're going to do is the idea with the Cryptomap is to have a you're going to have a Cryptomap it's a data plane filter, and it's used to kick off the VPN connectivity. So the idea is you're going to use ACLs to find the proxy ACL for the phase 2 configuration, and then you're going to apply that to the interface. And so it's like Cryptomaps are applied to physical interfaces, and then one Cryptomap per interface, always outbound with respect to traffic direction. And one Cryptomap can apply to multiple interfaces, and they are processed top down. That's the important thing to remember. And so we can have, let's see. So here's the order of operations. This is the important part, because if you're having an issue getting stuff working, this is why it's not working correctly. So encryption applies after routing, and then encryption applies after NAT. So crypto, NAT routing, NAT, and you should be good to go. So with the phase 1, you're going to have authentication, encryption, a hash, a Diffie-Hellman group, and a lifetime. Lower value is always negotiated, so you don't technically have to put this in. Authentication, encryption, hashing, and the group have to be put in place. Now, then you're going to have a policy, and policy is based on the crypto ISACAM policy is a kickoff config, and the lower the number, the better. So the idea here is actually pretty simple. This is actually our configuration. So what you're going to do is you're going to create a phase 1. So I'm going to keep this up here, even though I know how to do it. I find it easier for you guys just to have the configuration right there in front of you. So we're going to start on router 5, and we're going to type in crypto. I just say policy 10. And now remember that this is arbitrary unless you've got multiple policies. We're going to type encryption. We're going to use AES. The authentication is going to be a pre-shared key. We're going to use the hash, and we're going to use a SHA-256, and we're going to use a group of, and by default I believe it's 2. We're going to use a 5, and that's going to be our config. So do show run pipe section crypto. Now the reason I know this so well is because I've done it so many times with the phase 1. Now the nice thing about this is phase 1 for doing a static VPN, static site-to-site VPN between 2 different routers for phase 1 is identical to the way we're going to do it when we set up a crypto profile to associate that to the tunnel when we do DMVPN. Now the next one we're going to do is we're going to type in crypto ISACAM key, and the name is going to be, we're going to use CCNP, the address, and we have to specify the address we're going to connect into. So the peer address is going to be 115.0.0.2. And that's who we're going to connect into. You need to be specific with this setup because the fact that you're going to be peering with somebody directly. Now, the next thing we need to do is we need to go type in crypto, and we actually need to take that back. Type in we need to type in IP access list. We're going to say it's going to be an extended access list, and we're going to use the name of IPsec, and we're going to say enter. We're going to type in permit, and let me go check on router 11 real quick what subnet we have there. Do show IP interface brief. So we have the 192.168. So we're going to do a connection for that. So we're going to go back to 5, and we're going to type in permit IP. Permit IP. We're going to say the source address is going to be, where are we coming from? Do show IP interface brief. We're going to do, I'm going to configure a loopback and put that in the, we're doing 192.168, 100. We'll do 200 on this side. It's going to be, we're going to type in permit IP, and we're going to type in 192.168.200.0, 0.0.0.255, and the destination is going to be 192.168.100.0, 0.0.0.255. Okay, that's our proxy ACL. Next, what we're going to do is we're going to go and we have to actually type in interface loopback 200, an IP address of 192.168.200.5. And the reason why I'm doing this is so that when we go in there, we can source it off the traffic we're going to be coming from. And we could add in more traffic to this, but the drawback is that we have to be guaranteeing it's going to where it's got to go. So we can. It's easier if we just source off of it because we can make it look however we want to and go from there. So from here, what we're going to do is we're going to type in crypto. Actually, let's exit out of here. Crypto. We're going to say, let's see here, we need to do Cryptomap, and the Cryptomap name is going to be IPsec. And we're going to say, we're going to hit enter. No, wait, I'm sorry. IPsec. Cryptomap. Oh, the number. Sorry. Brain fart. IPsec. ISACamp. And we're going to hit enter. And it says this Cryptomap will remain disabled until a peer and a valid access list have been configured. So we're going to type in set, or we're going to say match the address in IPsec, hit enter, and then we're going to say set the peer to be 115.0.0.2. And we're going to do set the transform set, and we're going to say the name of the proposal is going to be R5_R11 question mark, and we're going to hit enter. And so, but it's telling us we don't have a transform set configured. So we have to type in crypto IPsec transform set, and we're going to use this guy right here. And we're going to say ESP AES, so it's easier just to double click on this stuff because there's a lot of configuration capabilities. And then we're going to say ESP SHA-1. This is basically what that is. This is a SHA-1 ESP, and this is the actual encapsulation to make everything encrypted. Now, because AH is authentication, this is not encryption. ESP is encryption. And then we get to type in the mode by default is going to be tunnel, which is fine for what we're doing. When we go into GRE over IPsec, we have to change it to transport. So we're going to type in the crypto map is going to be IPsec, and the 10, and then 10, and then the IPsec ISACamp, and hit enter, and then we're going to type in the set transform set to be R5R11, and we're going to do and hit enter. Now, nothing's going to happen yet until we apply a crypto map to the interface. So let's do a do show run pipe section crypto here. Let's review our configuration. Alright, so we have our phase 1 tunnel. We have this is phase 1 right here. Everything below everything not highlighted is going to be our phase 2 configuration. So phase 2, or phase 1 is telling me that I have, the encryption is AES, I have a SHA-256 hash, I have a pre-shared key configured with group 5, and then I'm going to have a key as CCNP. Now the key has to match on both ends in order for this to work. This is our router-to-router configuration. This part down here is going to be our LAN-to-LAN configuration. So R5 and R11 have to agree on this policy right here, and then down here when we get into it, we're going to see exactly how this plays out. But the idea here is to make sure that we have the correct configuration on the remote end so that we have traffic going back and forth where we need it to go. So I'm going to take this information right here, and I'm basically going to copy it into Notepad. And I'm going to bring up Notepad, and I'm going to copy it into Notepad, and I'm going to show you guys how this actually works. And I'm going to do a paste it in here. I'm going to come up here, I'm going to do a do show run pipe section access list. I'm going to copy this into Notepad, and this is exactly how I would recommend you do it. So I'm going to grab this guy right here and copy this. I'm going to come down here, paste this in. But what I'm going to do actually is I'm going to take this right here and go to the end. I'm going to Control X, pull this out, paste this in, and then that's the reverse side coming back to me. So now I have that in place. Now we're good to go. Now I get to go to router 11. And basically what I do now is I come over here and I know let me do a do show IP interface or do show IP route. And I want to make sure I have the right address coming in here. So 155 and do ping 155.0.0.2. I can ping the remote end. So that means I'm going to change this address to be 155. So we're going to be reversing the capability. And the same thing with right here at 155. And then everything else is going to match. So I've swapped it. So I'm going from 200. And you can see that's right here. So do show IP interface brief. This is the 100 side. So this is our source. 200 is the destination. We have our configuration up here for phase 1. We have our pre-shared key configuration and pointing to the address of router 5. We have a transform set that's going R5 to R11. We could swap this around because the transform set name is locally significant. It's what the calls. This is how it's encrypted. So the name is actually arbitrary. We could use any name we want. So I just want to make sure we have the correct configuration in place. So what I'm going to do is I'm going to take this information right here. I'm going to copy and paste it into router 11. I'm just going to right-click it in there. Alright, so everything else looks good. Now what I get to do is I get to go back to router 5, and on interface serial 2/0, I get to type in cryptomap, and I type in the name of the map is going to be IPsec, and the cryptomap name is right there. Right-click and paste that in. Now what's going to happen is ISACamp gets turned on. Go over to router 11. Go to interface serial 2/0 and type in cryptomap and then IPsec as well here. And then crypto will be turned on here. Now we go back to router 5. We type in do show, or so let's do this. Let's do show crypto ISASA. Now, nothing's going to happen until traffic actually gets sent. So what I'm going to do is I'm going to do a ping 192.168.100.11. I'm going to source it off of loopback 200. Loopback 200. Okay? You might be saying to yourself, well, you can't reach it. That is 100% correct. I cannot reach it. So now we have to go figure out what the problem is. Do we have a route to it? Is it advertised? You know, what's going on? So we have to take a look at this and say, all right, where do we got to go from here? So we're pinging this address, sourcing it from this address. So we type in show IP interface brief. We're going from this address over. So the thing we need to pay attention to now, and if the quick thing to do would be to do a quick debug. So we're going to do a debug crypto ISACamp and IPsec. What are my options? That, and then we're going to do IPsec because we have to troubleshoot both. And I'm going to do is I'm going to show you this live so we can see exactly how this works. And then we're going to test it. What do you call it? Anyway, I'm bother trying to think about it right now. I'm just going to ping. Alright, so nothing's going across. So let's do a show IP route. Do we even have a destination in here for it? Well, we don't even have 192.168.100 in here. So we don't even have a route to it. So what we're going to have to do is we're going to have to advertise the 192.168 route in on router 5. So we're going to go to show run pipe section BGP, and I can advertise the 200 route into BGP. So we're going to go to global config. We'll type in router BGP 12345 and type in address family IPv4 and type in network of 192.168.200.0 with a mask of 24 bits. I don't technically have to type this in, so do show run pipe section BGP. So it's advertised now. So now if we go over to router 11 and do a do show IP route, we should have a 192.168.200 route in here, which we do. And now we're going to type in router BGP 11, or I'm sorry, 12345, 12345. Type in network of 192.168.100.0 with a /24 mask. Go back to router 5 and do a do show IP route. We should have that route coming in via BGP, which might take it a couple seconds for it to propagate. Let me make sure I got the right configuration in here. Let's go back to router 11. Do show run, or IP interface brief. Do show run interface loopback 100. Okay, so it's in there as a /24. I configured it as a /24. Okay, so 5 should be learning this in. Let's do ping 192.168.100.11. Okay. Doesn't know how to get there. Alright, so what we have to do is, so it doesn't make much of a difference anyway. So let's see here. Router 11. Let me go to I'm gonna brain fart here. Why is it not coming across? Do ping 192.168.200.5. Okay, he can ping that way, but 5 can't ping back. Unreachable. Interesting. Wait, hold on one second. I think I might know the problem here. Do show run pipe section BGP, and I believe I'm doing allow ASN on this side. It may be the other side needs to be doing it too. I'm doing allow here, but I betcha. Let me go to 5, and we're going to type in neighbor of 155.0.0.1 allow ASN, and do show IP route. There it is. Okay, so now it should work. So let's ping 192.168.100.11. Alright, I can ping it now. Now let's do a source it off of loopback 200. It should be working now, and the bugs aren't even kicking off. Let's do a show crypto ISA, and nothing's even being triggered. So let's see here. Let's do a show IP route for show IP route for out. Let's see here. So show show IP interface brief. Oh, I've got to apply to the wrong interface, that's why. I need to go to serial 2/1. So show run interface serial 2/0. That's the problem. So config t interface serial 2/0, no. That's why it's applied to the wrong interface. And then you can type in interface serial 2/1. There we go. Ah. So now if we do that ping again, there it goes. So let me do a U all here. That's a good sign. That means crypto's working. That just blew up on me. But let me. I'm glad I did the U all when I did it again. Let me do it again real quick. So here, show crypto ISA. This means that we have a connection that's working. So we do that ping again real quick. It is working. It's a little slow, but it is working. So now if we do a show crypto IPsec SA, we have a active VPN between our router 5 and router 11. But you see how much work goes into this? It takes a long time, and I haven't even done anything special. I haven't put it inside of a GRE tunnel. I haven't done anything really fancy. It's just it's a static site-to-site VPN. And if it wasn't for me having BGP advertise the route, I wouldn't be able to reach it. So the idea with this is making sure you can actually have the routes propagate. Now, I did have, let me just kind of give you guys a brief overview of what you saw here. I'm not going to go through all of the detail here because there's a lot of information here. But the general idea here is this is the phase 1 negotiation. And there's several parts to it. I believe there's 6 steps to phase 1. And basically what this is telling us is we have a phase 1 configuration, and these are the attributes to phase 1, and they match. So we local pre-share key found, and then we're coming down here. Basically, it says that it's accepting the attributes and that everything looks good. So we come down a little farther. This is ISACamp, so this is phase 1. We come down a little farther, and then everything looks good. Everything's telling me that it's saying that everything is good to go. If there was a problem in here, it would be telling us. It would come out and it would tell us what's going on here. And if we come down here, we see that we have an address of 115.0.0.2, which is our local address, and the protocol 17, which is UDP. And then we come down a little bit farther here, we get into IPsec. IPsec means that phase 1 was complete. So basically what this is telling us is everything looks good here. We have, it says right here, attributes are acceptable. That's a good sign. If it didn't say that, we'd have a problem. And I have seen that plenty of time in production. Now we're coming through here, we have ISACamp. We have some specific information for this. And if you can see, I saw it pop through. Where was it? Right. Give me a second here. I'll find it real quick. I was watching for the pings to show up right here. This was telling me the pings were working. The first 1 or 2 weren't working, which was, I believe, let's see, where is it? Where did I set the ping off? I set the ping off, I don't even, right here. This is where the ping went. Here's the first lost dropped ping right there. Right? Come down a little farther, and I'm looking for the other one. Looking for a very small dot in a sea of other information, and we have the 3 exclamation points. So where the other one fell off, I'm really not sure. It could be right here where this main mode is sitting. That could be where the other one's sitting. That's the only other dot that I see. But that's telling us we're good to go. Now let's go to the other end. Now it's basically telling us that we have traffic was received, not an IPsec packet from this destination. So now if we come up here, we do a ping. We ping 192.168.200.5 and source it off of my loopback. What is that? Show IP interface brief. I forgot what the loopback is. Loopback 100. So ping 192.168.200.5 and source it off of my loopback 100. I have 5 good pings. Show crypto ISA. I have a active QM idle is a good sign. QM idle means that it's in quick mode, it's idle, it's working. So I do a crypto show crypto ISA show crypto session and hit enter. This is telling me that I have a key IKV1. I have it for this particular this is my local address on port 500, which is ESP. This is IPsec. And then going out to the remote side is 115.0.0.2 500. Then I have a permit. This is the flow that I'm actually allowing traffic for. So anything from 192.168.100/24 to 192.168.200/24, it's working. The origin is through Cryptomap. So it's up, it's active, it's working. So that's what I wanted to show you in this video. That's why it's a little lengthy, is to show you a static IPsec VPN. So what we're going to do in the next video is I'm going to show you a GRE over IPsec VPN, and then that's going to be adding a level of complexity. So I'm going to keep this VPN in place. I'm going to do some tweaks to make it work, and then what we're going to do from there is we're going to move into DMVPN, and then we're going to completely rip everything we've done out of the way here and start over fresh with DMVPN. I'm going to show you how much easier it is with DMVPN to get it to work. It's a lot less hassle. It's much simpler to get working. So go from there. So I hope this has been informative for you, and I'd like to thank you for viewing.